recorded.
Hello guys.
Hi, Vinamita.
Hey, good evening guys.
Good
Sorry,
evening, guys.
I'm busy with production release. Sorry. One second. Guys, do you have any doubts till last class? I hope everyone is practicing.
Yes. So when I practice that union and joins too, and I know how to join and how to union tables, but just to be a more clarify. So, like any condition, can you tell us about for the join? Like in what kind of requirement we use union? Normally, I remember you already told us that like a Walmart example. So like there are like lots of branches, they have a same attribute, column name. So that time if they want to see a record or like a report, so normally we join, right? Except that, you have any other example?
No, this type of all transactions always will use unions only. So based on requirement, you may get a lot of requirements in real-time scenarios.
Right. So what happened while I was practicing? There was a one requirement. There was a one table, and there is a one MView table. Okay. So and the requirement is we need to know that table and MView table are synced or not. So at that time in the solution, they are using somewhere union and somewhere minus. So like I know about the table, and I clear about I mean like I already know about the MView that you told us last class, but I'm just trying to understand like why they using union between that two table.
1 second. One second, I'm dropping on mail and 2 minutes just. Hey, Thiru. Guys, I'm back. Okay. Can you repeat your question, Abdullah? Abdullah?
Sorry, that's me, not Abdullah, that's Ashish. So
hey, Ashish,
that's me. No problem. So my question is I found somewhere like a requirement and solution together. So the requirement was there was a
hey, I'm
table.
able to hear you.
Sorry, hello.
Now I'm able to hear you. Go ahead.
Okay, so there is a table A, and there is a table A MView. Okay,
Table
and the
A
require
and table
table
view.
A and table A M view. So basically, the M view, like a what they call metalized view of the
Okay,
table A.
okay,
So
okay.
the requirement is they need to know these two tables are synced or not. So
Wait,
for the
wait,
solution, yeah.
wait. Why
Mhm.
are you mixing table and view, right?
Oh no, that was the requirement was there. That's why I got confused.
See, materialized view will not refresh by default. Based on your definition, it will work actually. For example,
Mm-hmm.
as I explained earlier, right? Materialized view, while building the materialized view, there is a concept called immediate or deferred.
Mm-hmm.
Okay. If
Mm-hmm.
it is immediate, when you create that materialized view, that will
Mm-hmm.
refresh that will refresh one time, first time. That is
Mm-hmm.
one case. But next time, the refresh method, if you use fast or full, on commit, on demand, two options is there.
Mm-hmm.
Two options are there, right? If
Yes.
you use on commit, when you
Mm-hmm.
commit the transaction in a table, immediately it will refresh that materialized view. If you mention on demand, you have to
Mm-hmm.
refresh manually.
Uh, yeah, I understood that one, but the requirement is different. So let me I write somewhere that just let me read. Okay, yeah, I found it here. So actually, there was a table A, and there is a table A MView, but that A MView table is created with two different tables.
Okay, you created with two different tables, no matter whatever it is.
Okay.
The refresh methodology is based on your materialized view creation.
Okay.
Okay.
So
So automatically by default, it will not refresh because if you mention on commit refresh,
mhm,
it will refresh automatically when you update immediately. You update or insert the record on a table. When you
mhm.
click on commit, automatically refresh. Otherwise, it will not refresh.
Okay, yeah. In the solution I see over there, they've been using a minus set or union set between that two query.
Oh, minus set.
That's
So even
yeah. That was my question. So why they use minus and union between that two table?
so okay. You have to ask this question. Then why are you mixing with MU and these things? I'm not understanding really.
That's why I asked you that one because the question is
Your question is your
same like
question is
this. That's why
okay.
I got confused. So let me explain everything.
Yeah.
You give me answer. So the
Okay.
question is there is
Mhm.
a table A and
Table.
one table MView but that MView table is created with table A and one more table C.
That
Okay.
means join table.
No. Yeah. So after that, the requirement was they want to know this table A and that MView table, which is created by two tables, they both are synced or not. So as in the solution, what they did, there is a query for table A and then union and then
Mhm.
query for MB table.
Mhm.
So why they use the union between that two tables?
I see the syncing. You are asking questions about syncing.
Thinking
About
right,
syncing,
right.
it will not tell you about this one actually. Maybe if you know the data,
Mhm.
see the data from the both the tables, maybe you can understand.
Okay.
But
Uh-huh.
syncing methodology is not correct. Whatever you are talking, that is not syncing properly. Okay,
Oh,
syncing
okay.
that is not. You are not checking syncing or not that case. You are combining the data from MU on
Mm-hmm.
a table. That is
Mm-hmm.
possible. Okay,
Mm-hmm.
so you are combining the data from
Mm-hmm.
MU. For example,
Right,
MU
right.
is same and
Mm-hmm.
table A structure is same.
Same.
Then you are combining together that table and this table. That is one way. And the second thing,
Mm-hmm.
table A, for example, you are going to check the raw method actually. Raw method means table methodology view have some data,
Mm-hmm.
and then you are going to run on table A. Table A minus methodology view.
Mm-hmm.
If you should not get any records. If you get some records, means that is not synced.
Okay.
That is validation. Yeah, this
Yeah.
is not. You see, the synced or not, you can check the record count actually. That table, this record count, you can match it immediately.
Okay, so
If you check
validation.
count of table A and
Mm-hmm.
count of metallurgy count, right? Both will tell you it's synced or
Right,
not.
right.
You
Okay.
can write minus operation also, but if
Yeah,
you
yeah,
want,
I see the minus operation over there too. Yeah, right.
correct, minus operation to check the data. What are the records missing in the metallurgy tube? That is what you
Okay.
want to check.
If there
Okay.
is no record populated, that means both tables are good.
Yeah.
Oh,
Both the data are synced. That's all.
synced. Yeah. Okay. Okay. Thank you very much. Yeah,
Okay.
that was my question.
Just that is you have to make sure that synced or not. Just you are check. Just compare the counts. That's fine to you, right?
Mm-hmm.
Table A
Right, right.
count. Get the table A count and table B count. You
Okay.
can understand if it is zero, both are coming as same. That's
Mm-hmm.
all.
That's all right, right. Okay, so we can use that word. Perfect. Thank you. Thank you. That's all.
That's clear.
Yeah.
Okay. Any question, guys? Any questions about this? Okay. Guys, we will create some indexes today. Okay. So what is the index actually? First of all, guys, for example, simple example, there is a textbook or something else, textbook or any content of the book. What is the content of the book? Which page it is? Right? The reference will be there, right?
Yes.
Right? Index. Any book you can see the index actually. Okay. The similar kind of thing in database also. We can create some indexes actually. Mainly, these indexes will use for improve the performance of the table, right? For example, if you see this MP number, comma, E name, MP. Just
We can see your screen.
sorry guys, let me share my screen. Okay. I keep forgetting this one to share the screen. Okay, fine. Okay, so just I want to see the data, salary. So I'm getting this data. So how many records we are having here? Around 23 records. Okay, and if you see this one, the structure, right? This is the plan about this one actually. This is the plan of the table. What method it executed, and it will tell you like this actually. For example, now I executed the query. It is going to table scan, table full table scan. That means where sal equal to 3000. Just I am giving 3000 here. Okay, we have two records here, right? And if you see the method, right, table full access actually. For example, now salaries are like this actually. For example, 5000, 3000, 2500, and 3000, and 8000. Okay, so like this. In employee table, we have very less records. That's the reason you can read out fast, and you can read the fast and then see the data. Right? You can read the data fast and then you can see the data immediately. Okay, we don't have any performance issue here. But imagine if we have millions of data in the table, employee table, we have millions of data. Now you want to see the particular record. Okay, what will happen here? Let me. Okay, we have some data, right? For example, take this one. 3,000, 5,000, 8,000, 9,000, 3,000, 2,500, and 2,000. Like this, we have data, right? So what will happen here? When you write select query, where salary equal to 3,000, if you mention that one, what will happen? Query will check this record, first record, and fetch the record, and second record, third record, fourth record, fifth record, sixth record, and then go on. Okay. If it goes that way, it will take too much time to retrieve the data, right? For example, if you have 10 records, you can fetch easily. But if you have millions of records or thousands of records, right, it may take a little while time, right? To avoid this one, index concept will come into picture. Okay. So what will happen? Now it is showing table scan here, right? Showing table scan. Okay. Now it is saying filter equal to salary equal to 3,000 now. So here it is going to full table scan and getting 2 records right now. Okay. The data is 2 records. We have 2 records and then getting the data, right? And then this is the table scan. After creating index on salary, what will happen? We'll see here. Okay. Index is again DDL command, create index. What object we are going to create? Object is index here. Okay. Index and index name, index name. In organization level, we have to mention schema name also here. Schema name dot index name. Okay. For example, here Scott is a schema, right? Schema name or owner, we can say anything. Okay. Index name on table name of column name. Okay, this is the index structure actually. In organization level, we will have table spaces also. Table space and table space name something will be there. Okay. Table space name. This is what we will do usually. While creating schema itself in organization level, while creating schema itself, they will have their own table spaces. Table will store into one table space. Indexes will store into separate table space actually to improve the performance and all those things actually. Right? Guys, forget about this. Just I am telling you for your understanding only. Don't go for this one. Okay, I will tell you later that one. Okay. So see here, this is the syntax for this one actually. Okay. Now, how many types of indexes here actually? Mainly, we have 2 types of indexes here. Okay. One is B-tree index, and another one is bitmap. Okay, bitmap index. B-tree index means if you guys remember in I think in computer science we'll have data structures concept. If you remember that in data structures, trees concept is there. If you remember that, you can understand easily this one. Okay. So what will happen? Tree. What will happen? Tree, right? Root will be there. Under that, nodes will be there. Child node, parent node, child node kind of thing. This will be like this actually. Okay. Clear, guys? again, by default, when you create index, by default, it will consider as B tree index. Okay, guys, bit tricky. Understand this. We have only two types of index. One is bit tree and bitmap index. In bit tree, the values will store as nodes format actually. Okay, root node will be there, and then and down below child nodes will be there. Like I mean, for example, our node value considered as 3000. Here we are writing the query is 3000, right? Okay, node structure will be like this. How can I say, man? Okay, let me explain. Okay, node structure will like this actually. Okay, and for example, consider 3000. This one. Okay. I'll use this one better. It's coming. Okay. Nodes, how nodes will be there? Okay. And then, come on. Okay, and this one we have some text. Text. Okay, 3000 and three parts, right? Here, this side, I mean, left side we have less than 3000, and right side we have greater than 3000. Consider as greater than 3000. For example, here 3000 and 2000, 1000 like this will be there. This side, okay. This side greater than 3000, 4000. I mean, up more than 3000. Anything it will comes to here actually. Okay, when it comes to salary equal to 3000, you'll consider that salary equal to 3000. Where is the 3000 will be there? I mean, right side greater than or equal to. Left side less than the root node actually, less than the root node. For example, root node is 3000. Up to 2999 will be at left side node.
Left side.
Okay, left side nodes will be there. Right side 3000 more than 3000 to 3 something, anything, it will go to right side actually. When you write a query where 3000 equal to 3000, salary equal to 3000, and then we'll check root node, and then where is the equal to operator? Right side, right? Directly it will go to right side, and then we'll check the 4000. 4000 again, the node like this, same node like this actually. Insert shapes. Say, different node will be there, right? Okay, here 4,000, consider as 4,000 here. And then again it will check left side less than 4,000 and right side again more than 4,000. Consider like this. Okay. So here I'm adding text again 4,000, 4,000 again less than 3,000, and it will check this node. It will come to here, and then this side left side will check. Again left side will check, right? So wherever equal to 3,000 here, and more possibilities, and left side here. Directly it will go here, and then from there it will go here. It will check here only. It will not check whole table. You understand, right? And child nodes will be there. How child nodes will be, right? Like this again. Two parts will be there. And the value here, we are adding 3,000. And here star will be there. This side. Star will be there. Star means row ID, address kind of thing. Okay. Row ID. If you remember row ID, pseudo column, you remember that? What is the row ID?
Yes, we remember.
Yeah, row ID.
1, 2, 3, 4.
EMP number, e-name, comma salary from EMP, where salary equal to 3,000. See here, this structure row address, right? This address will store there, the point wherever we are having 3,000, the address will store there. Clear, guys?
Mm-hmm.
So which is having 3,000, that address row correct exact address will store into there, that particular place wherever we are having 3,000. So that, and then find that address and then directly go to that record and then fetch the record from the database. Clear? It will not check row by row. It will not check this one like this. It will go to directly here and fetch the record, and then go to this record and get the here record. Okay. Let me create the index and then see the differences. What is the difference? See this one. The plan is this one. Remember this plan. I'm going to create. I'm taking the structure. I don't want the structure right now. Create index. Bit confusion. You can ask questions here. Scott. Just to understand the purpose, I'm mentioning the schema name here. In organization level, you have to use schemas always, because from your ID, you have access, but you don't have, you may not have the access for original schemas actually. Okay. Original schema access, they will give, DBA will give only dev environment. Sometimes some projects they will give up to QA. Okay. And the schema name, index name, just my referring purpose, I am giving just IDX. I will give this one, and then which table it is, EMP table, on EMP salary. Here also you need to mention schema name, Scott dot, who is the owner of the employee table, Scott. So that I am giving here Scott dot. Okay. Now I created index here, right? When I execute this query, see here what is happening. See the difference? What it is saying? Table access by index row ID batched. That means this row ID, right? The address saved in index. Based on that address, it fetches the record. How many records retrieved? 2 records. Clear, guys? This is what will happen inside internally.
Okay, one question here, Venu. So,
go ahead.
yeah, what is the use of table space then? So it will
Actually, what will happen, right? While creating database, they will have some segments actually. Each database will allocate to particular server. In server, they partition by each schema. I mean, each database, right? For example, multiple applications will be there actually. Okay, in the multiple applications, everyone have your own schema actually, right? And everyone have your own database. First of all, everyone have your own database. All the databases stored in the one server actually, right? Internally, each application team will use only one database, right? In the database, we'll have multiple users will be there actually, right? So everyone will create the tables, right? You will create the tables, I will create the tables. So some people will create the tables, right? So a lot of tables will be there. Okay. And putting into one table space, all the tables, that will give performance issues later. Maintenance is not easy, right? Tomorrow, if someone asks to DBA, we provide the tables, particularly related to this project actually. Okay, they may have to check and maintenance is not easy if you are not using table spaces. Okay, second thing is performance wise, it will be database performance will degrade. Okay, to avoid this one, some batches, right? Each schema, while creating a schema itself, they will create two table spaces actually. Okay, one table space is to store the tables, and one table space is used to store indexes actually. Okay. And if you see,
so
one second, let me see. The table card. One second. I don't think this is our one actually.
So basically, we can say the table space is the storage things for the tables.
Store and data files, right? These each one will store in each database. In table space also, we have number of data files will be there actually. Okay, and see something. Let me see where. Yeah, see here. This is the table space name for system, right? It's all tables under table space system, and each table space will have data files actually. Okay, data will store in the files format actually in the database DBF format. Okay. So you have to. I mean, you can go in depth actually table spaces, but we are not required that one actually. Just understand what is what.
Okay. So while creating the index, do we have to mention the table space then? Like
in organization level, even while creating table also, you have to mention table space name actually.
Okay, how do we know that this much of memory is allocated for this much of this table?
See, right? You don't need to check that all those things actually. What you will do usually, while creating a schema itself, they will create auto extend actually for the particular table space. DBA will allocate particular database. For example, index table spaces, right? Will have memory allocation is less memory allocation will be there because we'll not have more tables, just we'll have some indexes. That's the reason they will allocate compared to tables. They will allocate less memory in index table spaces actually. Okay. While using index only, we'll use that table space. Until that point, we'll not use them actually, right?
Okay.
And what they will do, some of the schemas, DBA will mention auto extend actually. If you mention auto extend until some point, the particular point, the database allocation is, some example, 80 GB, right? In that 80 GB and 20 GB for indexes and 60 GB for this one, like
tables.
that. They will allocate like this actually. And then what they will mention while creating table space, this table space can auto extend up to 60 GB or some buffer GB. They will leave some buffer, and then up to 50 GB something. Okay, until you reach your data point, data reaches to that 50 GB, will not have any issues. When you get issues, you can raise a request only to DBA. You will not do anything with that. Okay. What it will, you will get some error actually. You can unable to extend table space by 1 GB kind of thing. Whatever you mentioned, right? You'll get some error kind of thing. Based on that error, you can send a mail to DBA or you can create a request to DBA. They will take care of it. That's not your job.
Okay. So, but writing the table space name is nothing but is it allocating the memory or just the name?
No, just name only you have to mention. You don't need to mention any table space name actually. For example, if you see here, maybe you can go on deep right. So if you see a structure, employee structure, go here and check the structure here. Even you are not creating, by default, it will go to some other table space actually.
Okay.
In organizational, you have to mention that one actually, which schemas you have to mention that. See, and this is the table, right? See here, these all primary key and all those things is created automatically. And these are all, you don't need to mention anything. These are all, okay. Only this one, after this one, by default is going to use a table space. See here. Are you able to see?
Yes. Yes.
Okay. And even index is also going to, by default, is going to use a table space because you didn't mention anything. By default, it's going to use a table space. While running the query results will store into temp table space and then get the data. Got it?
Yes.
Internally, a lot of things will happen. These things, right? These things you don't need to mention. Automatically, Oracle will take care of it. You don't need to mention anything. Just you have to mention table space name only. Okay? Clear, guys?
Yes.
Yes.
Okay, this is completely DBA concept. You no need to understand these things. Just you have, while sending the scripts, you have to mention table space. Which table space you have to know which table space you are going to create the table or index. Okay, that if you know that thing, that's all. That's enough for you. Okay. Okay. Now you understand, right? What is happening once we create index? Okay. For example, I am giving greater than 3000 something, even though it will go to, sorry, row edit coming, right? Okay, let me copy and paste here this one for your understanding purpose.
Venu, how do we get this kind of output?
This one?
Yeah. Where we have to click?
Yeah. For that one, what you need to do here, you go to here, go here, set auto trace on explain. Okay, if you execute this one, by default you can see this because is already enabled. So that for example you can off it.
Okay.
Okay, now I unwanted extra explain. Okay. While offing, it's not required anything. Just now see, if you execute this one, nothing will show.
Right.
Okay. Again, you are on this one and explain. Now you can execute this one. I'll show you.
Okay. So then to use the indexes, we need to get this kind of output?
No. Just for understanding purpose only.
Oh,
this
okay,
is completely internally. You no need to show to anyone.
Oh,
Okay.
okay.
How it is working, you have to understand that thing only.
Okay.
So you once you create index, you don't need to show it to anyone. Actually, how it is working, that is up to you only. You need to understand that one only. Okay. If someone asks how index will work, right? That's what you have to understand these things. These are the parameters you need to see. And And one more thing, we have explain plan. There is how to explain plan. Okay. Explain plan. Okay, now it's see here, if you write this one, it will create as explain plan actually. Explain plan created. And here we can see how to see select star from 1 second. Select star from DBMS. There is a function explain something is there actually. DBMS X. DBMS underscore explain or something explain something. DBMS underscore. DBMS explain. Procedural function. Okay, this is the start. I think Scott doesn't have the privilege to this one. Package. We need to check that one actually. Okay, where is the package exactly, and then we have to execute. We can see this one this way also. We can see that explain plan. Okay. So when it comes to performance tuning rate, I'll explain this one. Don't think too much here. Okay. Now you can understand how to create index. Okay. Now coming to bitmap index actually. So okay, first one thing I want to tell you guys, index will work perfectly when we are looking for less amount of data. That means, for example, if you want to see 90% of data in the table, then if you are going with index, that will not give good performance actually always. Okay, when you are going with less than 30% of data, if you go with that index column, that will give good performance always. So keep in mind this point always. Okay. Okay. And then, so bitmap, if you are not mentioning anything here while creating index, right? You are not mentioning anything here in between, before index, right? You are not mentioning anything. That means automatically will create Bittree index actually here. Okay, on salary column. And when index will work, I created index here on employee salary column, and I'm looking the data for. I'm looking data for where name like
ename. Ename like. Where ename like.
Yeah, you're right. Ename equal to this one. Now see what it is showing. It's going to, by default, is going to table scan, full table scan actually. See here, full table scan, because you are not using indexed column in the where condition. Understand? So which column you are creating creating index, if you use that column only, it will go to that particular index. Otherwise, it will not go to that index. Okay, clear, guys?
Can you explain one more time?
What I am saying, index can be created only on columns, not on tables. Understand? Based on only we can create index on columns only. Okay, that means if you are creating index on salary column, if you use that column in where condition, then only it will go to index scan. Otherwise, it will go to full scan only again. If you are not using that column, it will go to full scan by default. Because your indexed column is not ename. It is salary. Clear, guys?
Yes.
Yeah.
Okay. Now coming to bitmap index, right? Bitmap index, this will work differently actually. It will store as bits format actually. For example, when we'll go to bitmap index actually. Okay. For example, less types of values in the table, in column. For example is gender column. How many possible values here actually?
3.
Maximum 3. Right? Maximum 3 possible values. Right? These type of cases will go to bitmap index actually, because categories are very limited column, limited values will be there on the column, particular column, and data is more, maybe for example, consider as some population data, population table, right? Population can have n number of records will be there. Okay, huge number of data will be there, right? In that, you may have male, female, and others also will be there in that one actually. So that case, all unique values are only 3. Unique values are only 3. Consider this point, guys. Okay, we don't have more number of, even we have millions of records also, we have only 3. Consider these 3. Okay, this type of cases will go for bitmap indexes actually. Okay, simple. While creating index, you have to mention bitmap in between, before this. Okay, that's clear.
So you mean we have to use bitmap for only like unique or less column values?
Less column values.
Okay.
Okay, less column values. So for example, what we can say,
Less column value or less type of column value?
one is gender example, and other one is what we can say, okay, banking. Banking also will not have that one. For example, okay, let me tell you guys. In organization level, how it will be, right? Some set of data, reference data will be there actually. Some set of data, reference data. For example, we are using reference table as department table, right? There is a department table here. In that table, we'll have only department number and department name will be there. The reference is there. And the department number we'll use in other table, employee table. We are using employee table, right? That means employee table can have multiple records, and each department have multiple employees actually. But in department table, one department number can have only one record, right? For example, 10th department sales, that means sales only. We don't have any 10th department in some other department name, right? We'll not have that one actually in department table, right? So for example, consider as only 10 records, 10 departments we have in the organization. So you know that you have only 10 records, 10 types of departments were there. And department name, we can mention as bitmap index here, right? Clear, guys?
Not exactly.
No, sir.
No. Okay. So what is your question here? Okay.
How do we know that index we need to create that gonna be for B-tree or bitmap?
That's what I'm saying, right? So for example, in population database, consider as gender column. Okay. How many possible values here? Gender column, how many possible values?
3, male, female,
Only
and
3. 2 or 3. That's all, right?
right.
Not more than. Do you think more?
No.
No, right? So we have only 3. That means unique values in the column, unique values. If we have less unique values, less unique values means, for example, only 3 or 4, that type of columns you can create bitmap index. Blindly you can go for bitmap indexes.
For real?
Clear? Hmm?
I mean, like, why we go for the bitmap
Because
index?
bitmaps, because the possible values are less, so only the bits format will store, and then when we'll try to fetch the data, will be fast.
Okay.
Data
Okay.
will retrieve fast actually here, right? So we
Yeah.
have only three bits here, 3 bits here. Just you are mentioning where I want to select all the records from population, where gender equal to so and so. Particularly directly it will go. It will not check anywhere actually. Directly it will go there and then get the data and then push it to your on your application. That's all. Simple, right?
But
For example,
this,
yeah, tell me.
but this will return like many records, right? You know.
Yeah, many records. Yeah, that's possible, right?
Yes. But if you want a unique data, like a single record, like just like how we did for the salary.
Uh, why are you thinking about single record here? Single record means particular record. You have to mention particular ID,
Okay.
right?
Yes.
So these are categories, right? These are category of data. Actually, you are trying to fetch the category of data. While,
Okay.
for example, if you want to get a particular record, you have to mention a particular ID.
Okay. So you mean so bitmap will give only the category of the data, not the single row value, row record?
No. Category. This is the category of data, right?
No. I understand that this gender is the category, but so for example, if you are creating a bitmap, bitmap index, so the bitmap index will return the single record.
Bitmap index will not return only single record. If you based on your requirement, I'm giving the condition here, right? Select star from population where gender equal to
Male or female.
male or female. I'm giving that
Yes.
one condition. Okay. If you want more filter, okay, then you can add another filter and so and so column equal to this one. For example, population ID. Consider as population ID. Population ID equal to number 10, number 10 or 20 if you are giving that one. And again, it will go to the filter, again, additional filter, right?
Yes.
Okay. That is the way you have to filter. But only gender will not give unique record. Yeah, I mean, one particular record.
Yes, but then what is the use of creating a bitmap then?
Okay. For example, I don't have, I have gender column, but I don't have index on that one actually. Okay. And you can create bittree index also here. But again, it will go to nodes format. Nodes format will take little while actually. Okay. And bits format will fetch very fast. Okay. That is one thing. And second thing, here, clearly, only 3 categories. Okay. Okay, you don't have index right now, and then you are writing the query where select star from population where gender equal to female. Okay, then how it will fetch? Because population table will have huge data, right? It will go to full table scan. First thing, it will go to full table scan, and then it will check record by record. First record we have male record, and second record we will have female record, and somewhere else we have again some male record and female record, and like this we have data, right? Every record it has to check, right? Record by record it has to check. If you have millions of data, how long it does take to fill the get the data?
Okay, so that is the reason we are creating index, right?
Correct. That's correct. That's the reason creating index. And
okay.
one more thing. And one more thing here. I'm telling you one more example here. And the millions of records, each record will have one address actually, particular address, row ID.
Yes.
Right? If you give bittree index, it will create all the what is that? All the row IDs, right?
Mm-hmm.
Again, it has to check all the address, right? You understand that or not?
Yes. So for example, one question. So if you are having 100,000 records, so if we do the B-tree index, then it will take at least like 10 seconds to get the data.
Yeah.
So if we take the bitmap, then it will filter the category, and again on that, on top of it, we have to create the index, like B-tree index. That's what you're recommending?
No. On category column, we are creating one bitmap index. That's all. One index. That's all.
Okay. So for the 100,000 records, if we create the category, probably it will filter like 30,000 records. So again, from the 30,000 records, if we have to fetch a single record, it will take a full scan, right? So for the full scan, it will take a lot of time again.
First of all, the stepwise format, right? First case, it will, for example, 100,000 records. Just it took one sample actually, 30,000 records. 30,000 records out right now.
Yes.
Now query will run on 30,000 records, right? The next where condition will run on 30,000 records.
Yes.
On 30,000 records, what are the column you are using? Okay, what are the column you are using? How much amount of data you are looking for that? And the column has been indexed or not. That is important.
Okay.
Right?
Yes. Yes. So that means we have to do the bitmap and a B-tree index
Bitmap
for a single column.
Single column bitmap only. One bit gender column bitmap index. And other column, what are the column you are going to use in a filter? That column will have B-tree index.
Yes. Yes.
You got it?
Yeah.
You can create n number of indexes, but same index will not be there in the same column. That's what I'm trying to say.
Okay, got it.
Got it, right? Each column can have one index. That's not a problem here. Okay. Particularly, that gender column will filter one category, and that means already when we create the index, all the female records put into one bit, and in that category only it will look that one and then get the data. Full data will fetch from there directly. Okay.
Yeah.
On top of that, you can create, you have created B-tree index on other column, right? That column filter will work here. Okay.
Okay.
Maybe while working on performance tuning, right, we can see that somehow it is working. Huge amount of data will load the data tables, and then we'll see how it works and all those things. Okay.
Sure.
That will give a clear idea on this one actually. So far, any questions, guys? I know a bit confusion. Please practice and just try to create the indexes. That's all right now. We don't have that much data, right? So you don't need to worry. And slowly you can understand how it works and all those things.
So when we create a table, so index will create it automatically or not?
No.
No.
When you create primary key, automatically one index will be created on that particular column.
Okay.
Until that point, we will not create any index.
Okay.
Index is a separate object in the database object.
Okay, but when we put a primary key in the column, so it will be
automatically.
I mean, there will be a B-tree index there.
Will create.
Okay. All right.
Indexes can see here. So what are the indexes we created? Just to this is the pk.emp, right? When you create a primary key, it will create an index, one index.
So
okay.
In query, how we use index in syntax?
Query will not use it. Query will not use index. So we will not write any indexes over there actually.
Okay.
See,
so this is only for the like internal process we need.
Yes. Ashish. Index is object. We'll create a table and table column, right?
Column.
And when you are trying to retrieve the data, we'll not mention anywhere indexes in that column actually. While using hints only, I don't want table scan. We can force to run in an index scan. That time only we'll pass the hints on that. Until that point, we no need to mention indexes on the column. That is the first thing. Okay, index is not a column value. Okay, index is the method of improving the performance. Okay.
Got it.
So don't think about this is the column. This is an object.
All right.
Okay.
Yeah, I got it. I will do some practice and then I'll ask you a question.
Right. No worries. So how it is, the employee is object, right? Employee is table is one object, right? Like index is an object only. Okay. So these are the columns. These are the columns in the tables. These are the values you have to fetch from the database. Okay. For that, to fetch the data, we'll use indexes to get the good performance. That's all.
So normally we use the index. I mean, like we create index in those tables where we have a lots of, I mean, like millions of records.
Millions of data, and when we want to fetch only 30,000, less than 30% of data,
Okay.
that time indexes will work. Otherwise, will not work.
All right.
That's what.
Got it.
Any questions, guys, so far?
Actually, we know I see like we have other indexes as well, right? Like clustered index, non-clustered index.
Clustered index, non-clustered index concept is there's like in SQL Server it will work actually mainly.
Okay.
Okay. The
So
categories only. Mainly we'll use in clustered index and non-clustered index. SQL Server will use it actually. Here we'll not give you any particularly clustered index and non-clustered indexes.
Okay. So it will be just a binary tree or a bitmap.
Bittree and bittree and binary tree and bitmap. That's all we'll use it always. And there is a one type of function. I mean, one type of indexes were there. One type of index is there. That is comes under bittree again. That is the functional based index actually. How it works, right? I'll tell you. For example, employee name store in a table, right? Sometimes some names stored as lowercase, some names stored as uppercase, right?
Yes.
When you try to fetch the data, it will fetch the data from the table. When you create index, an employee name, by default it will check that one. And particularly you want to check uppercase something. Okay, you can create functional based index employee table of upper of employee name. Upper of employee name, you can do that actually. If you do that one, particularly if you use upper of e name, then only the function will rise. Otherwise, it will not fire. Okay.
Okay.
And this type of things, where we will use, right? For example, we have a lot of null values in the table. If it is null values, more null values, even the index will not work properly, right? That type of things we can create NVL of the particular column, comma some default value will give that one. While creating index itself, right? NVL function will create index on that actually. Got it?
Yeah. Yes.
When we use NVL function in the in where condition, automatically it will fire. Index can will fire. Okay.
Yes.
And even if you create index on that column, if you are using NVL function, if you don't have functional based index, right? It will not fire. It will go to full table scan again. Right?
Yes.
So this is what you have to understand.
So if we have an index in our table or in our column, so inval function will scan only that column. Otherwise, it's gonna scan the whole table. You mean to say?
No. Again, it's missing here. That is called functional based index actually. That means while creating indexes, for example, commission column. I have a commission column. I have created commission column index. Okay, just blindly I created index on commission column. But in commission column, we have a lot of null values in the table, right? What I want to do when I'm writing the query, where NVL of commission null. NVL of commission means if commission is null value, set to some other value, some default value, some 0, something. I'm giving some 0. Okay, equal to so and so. I'm mentioning as some 10%, 30% like that. I mentioned this. Okay. Now I used NVL function in the where condition, right?
Yes.
But I created index on commission column, just commission column. Okay. This case, index will not fire because we are using NVL function here actually. The function, the index will not work properly. For that these type of cases, we'll create functional based index while creating index itself. NVL of commission, 0, we'll mention like that, right? When you mention that one, when you go to where condition and then you are using NVL function, automatically will fire that one.
Okay.
Clear?
Yeah.
Any
So
question?
you mean like create index scott dot idx underscore emp on scott dot emp, and the brackets you have to create NVL of
Like this.
like the column name. Yeah.
Let me create. I'll show you. And index names should not be duplicate, man. If I'm giving commission like this, okay,
Then the function will not work.
Function will not. When you use the NVL function, it will not work actually usually. So that one, what we will do, NVL of comma 0. If you create like this, right? Index created, right? Select employee where NVL of particular condition, you have to use it here. Then only index will rise. Otherwise, will not rise. Okay, rise and 300 greater than 300 something. Okay. See here. What is happening?
Index range scan.
Yeah, index space scan. For example, what is this?
Full scan.
Full scan.
Full table scan. Okay.
Yes.
That's the reason I'm saying, right? When you give a particular function, that particular when you use that particular function, then only the index will rise. Otherwise, will not rise. That is called functional base index. Okay. Clear, guys?
Yes.
Yes.
Okay. I think it's almost more than an hour. Okay. I think that's all for now. Any questions so far?
If possible, can you explain next week about a bit more in depth in Bitmap and Bitmap?
Once we finish this one, right? PL SQL part. Then we'll come to performance tuning part. Who are interested, you can sit with me. I will explain all the things.
Yeah,
how
sure.
indexes work, and how we can write query rewriting, and a lot of things, right? We can explore a lot more actually.
Sure. Thank you.
Okay.
And you're also going to teach us how to write subqueries, right?
Subquery is already we wrote, and then while using usage we can write it as simple. That subquery is nothing but is a inner query.
Query inside query.
Yeah, query inside query. That can be in select query. That can be in select class or where class, from class, anywhere can be there. Actually. For example, like this. Select star from employee where EMP number. You can write like this only. Select EMP number. It should be in class. It should be in class and inner query. First execute inner query. Employee EMP where the EPT number equal to 30. Okay. What will happen here is internally what will happen here is first it will execute this query. Okay. This result will act. This result will act as this result will use to input for this query, outer query. Okay. That means first it will execute, and then all the employee IDs will fetch the employee IDs. Actually, how many we have? 10 we have, right? These 10 employee IDs will use for this in class. Indirectly, it is in class only, right? In class, all employee IDs will use in class here actually directly. Then execute this one. That result will work for work as input for the outer query. Clear?
So this is subquery of select case.
No, this is in where class, right? This is
Where
in where class.
Where
This is in where class.
And what about the from class?
From class we can use it, right? We can use, for example, I'm using this one. Simply I'm using this one. Just so ideally, okay. Select employee number, comma e name from see here what will happen now. What we will get here? Can you guys explain me? Can you guys tell me what will happen?
So from that data, whatever you have in the table, you will get EMP number and E name.
EMP number and EMP E name from where will come?
Department number.
The department.
No, from the 30 records.
Okay. See here, guys. Here we'll get error. Why we are getting error is, okay, E name. You can ask the question as E name we have in employee table, right? Okay, you can ask that. But my from class, my from class, this is the subquery. This is returning only employee numbers only. I don't have a E name here. Okay. This I'm not getting data from employee table actually. I'm getting data from this subquery. Understand, guys? They are getting one. That means this column is returning only employee number only. We don't have employee name in this result set. Okay, that's the reason we are getting error. So when I am mentioning when I mention here e name, you get it or not?
Yeah.
So if we are using a from class, so whatever come with the select
yeah, that will act as a table now. Now that will act as a table.
Okay.
Okay, that will act as a table for outer query. See here, how many columns we are getting? Star, 2 columns only, right? When you add any more columns here, automatically you'll get 1 more column. How many columns? 3 columns. Okay. This is the way we have to write always.
Right.
So always subquery will execute first, and outer that will act as input for the outer query.
Correct.
Okay.
Yes.
Yes.
Anything else, guys?
Nothing, I guess.
I think we can stop here. It's almost Friday night. Yeah, go ahead.
Yeah. I think we are left with like still more things for SQL, right? With clause is there.
With class, we have to write, and that is completely temporary. It will act as temp table side. We have to write with class, and we have to write some methodologies. Actually, those are completely comes under select queries only, right?
Yes.
We need to write some methodologies. While practicing, we'll write those things. With class, we have to write, and then we'll write some critical queries, all those things actually. How complex queries we can write.
Will you be using list tags and list tags also, like with clause list tags?
Those are analytical functions. You guys can practice them actually directly. Okay, list aggregation and lead, lag, lot of functions were there actually. I explained how to write. Just see that, and if you have any questions, just ask me. We can do that. Or else we have some set of queries actually. We'll practice them. Okay.
Okay, sure. Thank you.
Just I'm covering the concepts right now. How cover? I mean, I'm not going in depth actually. Just I'm covering the concepts, and then what we required for this one PL SQL blocks. Okay.
Okay.
While writing SQL queries in PL SQL, we can write with class and
case statements and decode.
Statements, decode, and these are all things we can write it.
Okay.
Okay.
Okay. Yeah, sure.
A lot of things were there. So while writing PL SQL, we can understand a lot of things, Ram, actually.
So debuildings you'll be doing after the PLSQL course, right?
After PL SQL, yeah, because
Okay.
that is not much important for us. We'll go for later, last one. Okay.
Okay. Yeah. Thank you, Venu. That's all I have.
Okay, I think because I'm not following content of the table actually. Whatever I required, I'm covering those things actually. That's all. Okay.
Okay.
I think we can stop here. Have a good night, guys. Have a good weekend. Let's
You
meet
too.
on Monday.
You too, Venu. Thank you very much.
Yeah.
Bye. Take care.
Good night.
Bye. Good night.